Hey there, welcome to Technoggin. So today's topic of discussion is quantum computers. Now before we dive in, I will give you the introduction on the fundamental working of a conventional computer, just so that you can relate to it when we come to quantum computers. So let's get started. Since the 1960s, we have observed an exponential growth in processors, which has allowed them to become more powerful and smaller at the same time. But this growth is about to reach its physical limits. The computer components are getting smaller and smaller every day, such that they are approaching atomic scale. At its core, computer is a machine able to do simple arithmetic operations on the data provided. Now let's take a closer look on the processing of a computer. Now all the processing of a computer is done by the CPU. The CPU can be divided into basic modules, which further divides into logic gates, which consists of transistors. A transistor is the simplest form of data processor in computers. It's basically a switch which allows or disallows the flow of electrons. The data that is processed by the computer is in the form of binary, that is 0 or 1. More formally known as bits. The computer reads the flow of electrons as 1 and absence as 0. Now these bits can be combined to represent more complex data like an image or an audio. Transistors are combined to make logic gates, which take two inputs and give one output to perform simple tasks. For example, AND gate gives the output 1 only when both the inputs are 1, otherwise the output would be 0. Now these logic gates are combined to make a basic module to get a meaningful output, for example addition of two numbers, or subtraction, multiplication or division. Once you are able to perform these basic operations, you can do anything. Since all the operations are literally easier than the second grade maths, you can simply think of a processor like a bunch of second graders. A large group of them can compute anything from astrophysics to running simulations. But shrinking the size of the processor complicates things. A transistor is a switch which can block the passage of the electron flow. Today, a typical scale for transistors is 7 nanometers, which is 1,000 times smaller than the diameter of a red blood cell. As transistors are shrinking to the size of only a few atoms, electrons may just transfer themselves to the other side of the blocked passage. Confused? Well, when you're working at an atomic scale, the laws of conventional physics don't apply. This is where quantum physics comes in. And in quantum realm, traditional computers just don't make any sense. We are reaching the physical limits of our progress. That's why scientists are looking to use the laws of quantum physics to their advantage. In comes quantum computer. In traditional computers, bits are the smallest form of information. The quantum computer uses quantum bits, or also known as qubits, which can also be set to one of two values. A qubit can be any two-level quantum system, like a spin and a magnetic field, or a photon. 0 and 1 are the two possible states in which the system can be, like the vertical and horizontal polarization of a photon. In the quantum realm, the qubit doesn't have to be just one of those. It can be in any proportion of both states at once. This is called superposition. But as soon as you test its value by sending the photon through a filter, it has to choose one. So as long as you don't observe it, the qubit can be either 0 or 1. Now that's a game changer. As 4 traditional bits have 16 unique values, but you can use only one. While 4 qubits at superposition can have all 16 values at once. This number exponentially increases with addition of each qubit. Like 20 qubits can store more than 1 million values in parallel. Another weird property that qubits have is quantum entanglement, a close connection that makes each of the qubits react to a change in the other state instantaneously, no matter how far apart they are. This means when you measure one entangled qubit, you can deduce the value of its partner automatically. Now that's a mind bender as well. A traditional logic gate gets two simple inputs and produces one definite output. A quantum gate manipulates an input of superpositions, rotates the probabilities, and gives another superposition as its output, which means that you can calculate all the possible outputs that you can get according to the inputs at once. So the quantum computer will not replace your conventional computer. However, these would be used to generate simulations with multiple scenarios and calculate all the possible outcomes with more accuracy and a faster pace. Or another field where they can be of great use is database searching, where a conventional computer requires to check each and every value to complete a search. Quantum computers take only square root of that time, which in case of large databases is a huge difference. The most famous theoretical use of quantum computers is to ruin the IT security system. Today's data security relies on the fact that the conventional system would take years to find the correct key to decrypt the encrypted message. But for a speedy quantum computer, it would be a matter of hours. However, these all are theories, as you require the quantum computer to be in an ideal environment where temperatures are closer to absolute zero, that is minus 273 degrees Celsius, and there is no radiation. A lot of companies are putting their efforts to turn this concept into reality, such as IBM. They say they'll have a fully functional quantum computer in 3 to 5 years. But would it be at par to our current generation CPUs? I don't think so. I believe it would take a couple of decades for quantum computers to increase their performance exponentially, such that their throughput would justify the immense amount of energy that they would consume to maintain their ideal conditions. If you liked the video, please do like, share and subscribe. This is Technoggin.